So we've covered pretty much a good selection of the basics in JavaScript. They should offer you some good functionality to be able to integrate with the Uniface. So we're going to now go on and have a look at how to include JavaScript in Uniface and use our JavaScript API. Move on. Okay, so starting with Uniface 9.5, we introduced the JavaScript API. What it allows you to be able to do within the DSP web application is to interact with the data on the client, the data and also any fields that data is bound to. So when you start using the JavaScript API, it might be a bit strange to start with, but it actually contains a lot of the familiar functionality that you get within Uniface. So it has the concept of instances, it has the concept of entities, occurrences, and fields. Okay. So from a instance, and you can get an instance by using the getInstance command of the Uniface object, so uniface.getInstance. You can then navigate through to the base entities which are painted in the DSP component. You do that by using the method of getEntity. So now we have uniface.getInstance.getEntity, and it's passed just a string of the entity name, the fully qualified entity name, so entity.model. Okay, this is not so. This is very similar as you do as you sort of traverse through Uniface. You don't have so the next idea is the next thing you have to do is then go through from the entity into the occurrence. So Uniface has occurrences, and so here we have getOccurrence, and then you pass in a JavaScript index for the occurrence. So here I have occurrence number 1. This is slightly different to Uniface because occurrence number 1 is actually the second occurrence. Because in JavaScript, indexes are always starting with 0. So we have 0 would be the first occurrence, 1 would be the second, 2 would be the third, and so on. So once you have an occurrence object, you can then, from within that, go and get a child entity, which would then just be another .getEntity command, or you can get a field. So here I have a field. So get field and then a field name. Again, it's just a string. It's just the field name within that entity. Once you have the field object, you then can go on and interact with it further. So you can now do things like get value or set value. You can set a val rep on it so that it appears in a drop-down list. You can set properties. Properties are available on higher objects as well. So yeah, it's very similar to the client server. It follows the frames within frames which you have defined within your DSP. The documentation, the Uniface library, documents that JavaScript API quite completely. And if you want to look for it, you open the Uniface library, navigate to reference in the Uniface reference in the tree, and beneath that you have APIs and JavaScript. And that will give you all the information about what can and cannot be done with each of the objects within Uniface, within the Uniface JavaScript API. So we went through some data types earlier, and the reason why we did that was that we could have a look at some of the functions which are in Uniface, and these just a very few of the functions within the Uniface API. And just to explain that different functions have different ways of interacting with them. So things like get and set value just take a string parameter. So get value, set value, open bracket, in quotes your value, close brackets, semicolon. Sets the value of the field if it's run on the field object. Some other Uniface methods within the API take an object. So things like get and set properties, they allow you to be able to set many properties against an object at one time. So you would define this by having the set properties, open bracket, the curly brace, the identifier, colon, value, comma, identifier, colon, value, close curly braces, close bracket, semicolon. so that you can build up some, you can create a bunch of properties at the same time and assign them in one command rather than in multiple. And very similar, you can also set arrays. So you can use arrays on some commands. So for instance, set valrep array. Again, just to recap, arrays are defined as square bracket, comma separated list of values, close square brackets, and then again at the end of the line, semicolon. Okay, so that gives you a that allows you to be able to set array data. So to define functions within Uniface, which are going to be available to both the Uniface JavaScript API on the client and also from the client to the server, to be able to set, to be able to create an operation which is accessible in JavaScript on the client, you would use the web operation that allows you to be able to activate that operation on the client. And to create an event against a field, you can use the web trigger. So have a look in the documentation again for the different widgets, and you will see which events are available for each of the different widgets. So they are subtly different from each of them. Both the web trigger and web operation have a very similar definition or very similar structure. So the web operation itself instructs Uniface to wire it up within the browser. Okay, so a web operation, say hello, would instruct Uniface to create an operation that is callable in the browser called say hello. A web trigger will cause Uniface to bind an event to an object in Uniface. You would then have a scope, or you can then have a scope, it's optional. If you don't put it in, it's both input and output. Input and output will define the direction of data that will flow between your application and the operation. Okay, so an input will package up the information which is within the DSP and transmit it, and output means that the operation will return data which will then be deconstructed and placed into your component on the return. You can then have a again optional parameter block. In Uniface, although JavaScript does not support input output parameters, Uniface does. So there is a way of being able to create input-output parameters, in-out parameters, as well as just input parameters. You cannot have output only, and there is technical reasons for that, and it is around having to call Uniface with a full list of parameters. There is also the optional JavaScript JavaScript block. Okay, so if there is JavaScript in a JavaScript block, then it will be compiled up into the Uniface's DSP.js file, or the components DSP.js file, and will be included with the page, or the fragment of the page. If you don't include it, then you have to include the JavaScript which you're going to be using manually within the application. But what it does allow you to do is for a JavaScript developer, a dedicated JavaScript developer, to develop these functions in these operations externally to Uniface if that's what he wishes to do. So use the tools which he's used to using elsewhere. But in the end, the same information, whether it's created from within Uniface or externally, all go into files transmitted to the client and then are called at the relevant time. So while you're executing your code within JavaScript, you'll find that you'll be within a context. So if the JavaScript web operation is being fired, there will be a variable within it called this. This will be a reference to the instance of the component instance. Okay, so if you were wanting to find an entity within that DSP, you would use this dot get entity. Okay, it just allows you to know where you are within that structure at the time. Likewise with webtrigger, the this is a variable that contains your current context. So for webtrigger, unlike operation, operation is on an instance of the component. The webtrigger, the this is an instance of the field. Okay, the field in which that has been defined. If you want to traverse from something, if you want to traverse up the line, so instead of going from the top level to the bottom by using the get entity, get occurrence, get field, etc., if you want to go to the parent, you can use get parent. So that will take you from a field to an occurrence, from an occurrence to the entity, from the entity to either parent occurrence or the DSP itself. So you can traverse back up the line, and then from there work your way back down again. The activation of functions and web triggers, or functions mainly within Uniface API, are done asynchronously. So what this means is that although you might activate an operation, it will be queued for a later time. So when the environment isn't so busy. In order to be able to make code easier to read and to interact with, there is a thing called promises. So probably it's worth first of all explaining why where the trouble is without using promises, and then we'll have a look at what promises offer you. So a promise, so without promises, what you would do is you would have to call into an operation. That operation would not be in line, it would not be synchronous. So the trigger in which it was called would finish, and then the operation would be fired. But how do you then interact, or how do you then do further processing after that asynchronous operation has been after that asynchronous operation has been completed? What you would have to do is to make another call from within that operation back to where it's called from, so that you can do more processing. That means that you're sort of starting to get a lot of code where you go from one place to the next. The code is distributed. It's not easily discernible. You can't find out what it's meant to be doing easily. To get around this, there is a thing called a promise. So a promise represents the eventual result of an asynchronous operation. It is a placeholder into which a successful value or reason will materialize. Okay, so what that actually means is that after a create instance or an activate from within the Uniface API, so here we have an example of create instance. Okay, we can then follow that up with a .then. Yeah, so the create instance will return a promise. Okay. The .then will be executed by that promise when the asynchronous call has been completed. Okay. So here, as I say, we've got a create instance. We're creating an instance of the address DSP. We're going to be calling it our ADDR inst, and we're going to fire an operation called lookup coordinates. We're going to be passing it our address. Once this is finished, it's going to return information back to Uniface. Now this could be in the data structure, or as I say, it could be in as an in-out parameter. If it's an in-out parameter, within the ret value variable, there will be an args property, and inside there will be an array of parameters. There'll be one per parameter passed in. So these are in-out parameters, or in-out parameters, and they will all be available. So if you have two parameters which are in, then one which is in and out, there will be three items in the array. The first one will be the first in parameter, the second in parameter, and the third one will be the value returned from the in-out parameter. Okay. There will also, on that returned object, be an instance ID. Okay, so the create instance has created an instance ID which we can then interact with. So here we are going through and we're getting an entity which is located on that entity. So this is the entity is called C, a very catchy name, and the model is called location. and from there we can then go and get the occurrences. Yeah, and then we can do something with it. So for here, we're firing off a Google Maps. If there's a problem, if we have a problem, there is also a catch block that is fired, and in there we'll document what that problem is. So a kind of things that could be problems is that it could be that it's an incorrect instance name, perhaps the function being asked for isn't callable from outside of the component itself, perhaps the network is down, etc. That kind of information will all be handled in the catch block, and they will be passed into this E parameter here. These are not fixed names. You can pick whatever name is useful for you. It's just that is where Uniface will return its information. So very simply, that's how you include JavaScript into a Uniface DSP.